I'm going to be talking about using AI to help you code for the Pico, or actually um, for other things as well, the Raspberry Pi. But the focus of this talk is going to be coding for the Pico. And the reason that I started doing that was to help me build projects faster and to use technology that I was less familiar with. And in case you haven't come across them, I'm sure almost everyone here will have. That's the Pico itself, the baby brother of the main Raspberry Pi, which came out in 2020, and it runs MicroPython, so it's really easy to program, and you can do loads of fun stuff with it. So why worry about AI? Why think of using AI to help you code for it? Well, AI knows a lot of stuff. It can program quite satisfactorily in MicroPython. It knows about CircuitPython. Unlike me, it knows how to program in C++. It knows quite a bit about less common but quite useful languages like Forth. And it knows about all the different variants of the Pico, including some very recent products. I was showing Richard just now a thing called the Pimoroni Pico Explorer, which has got a screen and a breadboard and sound base. And it's only been out for a few weeks, I think. And some of the LLMs that you can use commercially already know enough about it that they can write code for it. So AI is pretty knowledgeable. And what I want to do this evening is tell you a bit about what I've experienced so far, give you some examples, both for programming and also for doing research, and also tell you about things I've found that worked and one or two I've found that don't. And hopefully after that, we'll have time for a bit of discussion. So who am I? I've been playing around with hardware and software since 1958. But there's lots of new stuff to play with. I was an enthusiast for the Raspberry Pi even before the product launched. I could see it was going to be good. I've used the Pico extensively since it launched, and I'm still learning stuff all the time and enjoy sharing it. I hope if you're sticking with this, you'll be able to make the same sort of use of it that I have. Use it with platforms you're not so familiar with, maybe experiment with languages you're not so familiar with. And it's actually a lot of the LLMs are very knowledgeable about some quite sophisticated software techniques so that you can get the LLM to do some quite non-trivial code. And then the last thing is it's really great if you want to use a piece of hardware that you haven't used before, because A, LLMs know about quite a lot of popular hardware, and B, at the end, I'll show you a neat trick which can extend its reach and your reach even further. So most of the rest of the talk is going to be taking a look at things you might want to do and code that does it. And all of the code that I'll be showing was written by AI under direction. So my first experiment was really simple. It's the thing that we all do when we start playing with a Raspberry Pi or a Pico or just about any hardware that's good for physical computing. Get it to blink a LED. So the prompt was simply write some code to blink the LED, the onboard LED on the Pico every second, and immediately an LLM came back with that code, which is exactly what you or I would have written. Slightly more sophisticated. This was one of the things that I did with an earlier version of the Pimoroni Explorer, thing called the Explorer base, which has been around for a while. I asked it to write me a script which would look for a button being pressed and then buzz the buzzer when the button was pressed. And again, instantly came up with code to do exactly that. And again, the code's just what I would have written. I love using OLED displays. One of the nice things about the Pico is that there are lots of fairly inexpensive OLED displays that it can drive, but it's sometimes quite tricky to track down the drivers, and it's sometimes then quite tricky to find good examples of the code. So I asked it to find a driver of the display which I wanted to use, and then asked it to write some simple demo code for it. It found a usable driver very quickly, searched around on GitHub, found it, gave me a link. I downloaded it and deployed it on the Pico, and then asked it to write some code appropriate to this meeting. And that's what it came up with. And sure enough, when you run it, it works. And worked first time, didn't need any debugging. So far, all of these examples have been fairly simple. But recently, I had a more difficult problem to tackle. Still not world-shattering, but it quite fiddly code. And the background was this, that a while back, Pimoroni shared some code for the Pico, which would allow you, if it's connected to a piezo buzzer, to type in the notes of a tune, and then the code would play the tune for you. Trouble is that the code which they published, which was based in turn on something that was written a while ago on Tom's hardware, it had a huge 2-page long set of magic numbers which mapped notes to codes, to frequencies. And I hate magic numbers in code. How did they get them? Well, I did some research using ChatGPT, and then asked it to help me write code to implement what I learned. And is that readable? Okay, so right down at the bottom, you can see a function called frequency for note, and you give that a string, something like C or C sharp or D flat. And what that function will do is translate the name of the note into a frequency in hertz. And to do it, it sets up some Python structures earlier, and you can see it starts off with the names of the notes in the octave. This particular version is able to cope with 8 octaves. I generate the names for all of the possible notes annotated by which octave they belong to. It turns out that if you're using what's called a well-tempered scale, each semitone is a fixed amount higher than the semitone below it in terms of frequency. So the next bit of code turns that into a number based on the starting frequency, which is the concert pitch A. And then something maps the names into the tones. And then there's a real weird thing, which the original software didn't do at all. Some musical notes have 2 names for the same note. So C sharp and D flat are actually the same note. And so this extends the lookup table so you can use either name. And then finally, the data that's been set up is used by frequency for note. And having done all of that, there's a really quite simple function which will play a song. A song in this case is a string of note names and P's. The P stands for a pause, and the code uses the plotone function which we just described, and it draws a rather pretty picture of the tones as the music plays. Does that on the OLED screen. All of that code was written by AI. It was quite a lot of direction and encouragement from me, but it did all the hard work, and commented as well, by the way, which is quite cool. So I mentioned that it was also quite good at dealing with things that hardware that you didn't know about. I'm writing this booklet, which I mentioned earlier, for Pimoroni, about how to use their Explorer. And one of the issues is that I thought I needed to work out the value of some load resistors. And I've been doing that on and off for years, but most of the readers probably haven't. And even more confusing, the LED which I was using is a 3-color LED, and I knew nothing about it. I knew where it came from because it had a part number description, but I knew nothing about it. So what I did was feed it the document on the left of the screen. That's actually a data sheet, partly in Chinese, from the Chinese company that manufactured the LED. And I'm only showing one page of that data sheet, but it swallowed the whole thing as a PDF. And then I said, okay, can you work out what load resistors I should use, given the basics, given the information on the data sheet? And back it came. The thing that you can see on the right is not what I typed. It's the formatted answer that came back from the LLM. So it's done a little bit of reasoning. It's formatted the formulae using LaTeX. And then at the end, it suggests resistor values and adds a little note to me, warning me that one of the resistors is quite low, and that I might be wise to go for a slightly higher resistor. So it's acting like quite an experienced electronic engineer. So fairly amazing. What LLMs am I using to do all this stuff? Well, quite a lot of different ones. I started out with OpenAI, been using that for various things, including a lot of other code generation for quite some while. These days, probably my favorite is Claude's Sonnet 3.7, which is a really smart agent when it comes to coding. I also these days use Windsurf quite a lot, and for various things make use of Mistral. Actually, the most useful thing about Mistral is that they've got a world-class LLM, which is specially tuned to converting PDFs to Markdown. And if you want to take a PDF and turn it into an editable document with conversion of tables and formulae and images, take a look at the Mistral PDF. It's not free, but it's pretty inexpensive, and it does a better job than anything else I've used. However, we're talking about coding. One of the things that surprised me quite early on was that there are some very small models, small enough that you can easily run them on your home computer, which do a pretty good job of code generation. The two that I've used the most are one from China, the Quen 2.5, and didn't have time to do it today, but tomorrow I'm going to be experimenting with its successor, Qwen 3, which is allegedly even better, and also a Microsoft model, 5.4. These are small models by today's standards. Qwen's got the version of Qwen that I'm using has 7 gigabytes. Oh, it's 7 gigabyte size set of parameters. Phi is about twice that size. You can easily run those on a home computer, even if it hasn't got a GPU. Bit slow if it hasn't got a GPU, but you can do it. And the small Qwen model will just about run on a Raspberry Pi. Only if you've got a lot of time on your hands, admittedly. But you can give it a job to do in the background, go away, have your supper, and come back, and there's your code done for you. So pretty amazing, but it doesn't always work. One of the things that went wrong when I started trying this, exploring using it with data sheets, was I tried a trick which I'd heard that Limor Fried of Adafruit had done a while ago. I gave an LLM a data sheet for a chip, an I2C chip, and asked it to write a driver for me. And it actually wrote some quite plausible code, and sure was it didn't work. And it failed in quite interesting ways. And sometimes, if you just give it a simple coding job, LLMs will make mistakes. They've learned from code, and not all code on the internet is good. So they're perfectly capable of making mistakes, vital to check what it produces, and any replies to questions about documentation. Of course, you need to test the code. And I tend to work in an environment that has Git in the background so that I can take snapshots as I code. And if you do that, it's a good idea to commit very frequently, because once in a while, LLM coding agents can go wild and just wreck an entire code base. It's only once happened to me. I know of quite a few other people it's happened to. So you need a safety net, and making sure that you're using version control and taking snapshots frequently is a good thing. I'd like briefly to mention one other thing which runs on a Raspberry Pi, but when I first wrote it, I was actually writing it for use in a workstation. It's a thing called Spear GPT. And I must apologize for the layout. I'm absolutely hopeless at designing GUIs. But basically, what Spear GPT allows you to do is it allows you to pick a local LLM model and then type a prompt and then ask for the prompt to be run. And then it will display a session in a window. And then you can save that to Markdown. So you've got a complete record of everything that you typed and did. So why am I talking about this? Well, all of the code for that was written by AI. And perhaps more surprisingly, AI also wrote code to do automated tests on a Python GUI. That's a non-trivial task. And what it did was go off, read the documentation for GUI 0, which is the Python package I used for that, work out how GUI 0 was doing its own automated testing, and then adapt that code so that it would run against the code that it was writing. So there's now a completely automated test suite which checks that this thing works as it should do. And again, all written by AI. Looks like I've repeated that slide. Sorry about that. That's the presentation. Anyone got any questions?
So you write the, so I get AI to write the code, you feed it directly into the Pico and it just works.
Sorry?
When you feed the code into the Pico, it just works just like that. There's no sort of, you have to mess around with it at all.
It depends. But generally, I tend to develop incrementally. And so one of the things that I've got set up in PyCharm, which is what I mostly use for development, is an external tool that allows me to check the code looks okay in the IDE, and then I just click an external tool button and it downloads it to the Pico, and then it will run it on the Pico. So it
Right.
makes for a very fast development cycle. Um, a lot of people don't use IDEs. A lot of people use Tony.
Right.
And one of the lovely things about that, of course, is that you've got a REPL, a read, evaluate, print loop. So you can actually type code in Tony and it will run immediately on the Pico. And again, that's a good way of testing stuff.
Right.
But
So,
most of the time, the code that it generates works. It quite often needs a bit of tidying up if you want it to look a bit more like code that a proper engineer would write. But
right.
most of the AI coding tools and agents will do that if you give them a bit of a prod.
And how many iterations did you have to use to get the more complex example of the frequencies and the music, playing the music?
Uh, I think all of that took about half an hour.
Oh, wow.
And part of that was just reminding myself about what the math behind the frequencies was. So pretty quick. And it wasn't that it made mistakes. It was that I broke the task down into fairly simple stages, and then got it to do a bit of tidying up.
Right. And even though the AI is creating it, you're able to understand the code quite quickly.
Hmm.
It's not like doing anything crazy. It's just we're using fairly
Yeah.
structured,
Well, I mean
very
that's largely. So this is my vanity showing now. That's largely because I was giving it pretty specific directions about which bits to do, but it did a great job of picking names.
right. Yeah.
And again, something which isn't so important with a Pico. Bruce, hi. You got a question now?
It's all right. You carry on.
Okay, I'll
Right, you.
stop in a second. But one of the things which it's really AI generally, all the coding agents I've used are really good at are writing project READMEs. They will write
Right.
an entire README with all the sections you'd want to find there just by looking at the code base, which is
Yeah. I
great
know
because it means you actually do the README.
it
Bruce,
does have
sorry,
the comments as
you're
well.
going to ask.
Yeah. And it has comments as well, which I thought was quite interesting.
Yeah.
Yeah, just to follow on, Romilly, a couple of observations really in what I've found. First of all, like you asking it to write the README is great, or just document your code.
Hmm.
I find that really useful.
Yeah.
Uh, and now and again, it will generate something that you think, what the devil does that do? And you can just ask it, what does this line actually do? And it just
Yeah.
tells you. It's great for that. Another
Yes.
one, which a friend of mine has got me onto, is after you've been through the whole conversation, you know how you start with one question, that's not what I meant, I'll ask this bit as well. And you keep asking additional questions and refining your prompts. At the end of
Hmm.
all that process, what he does, and he sort of demonstrated this, was to ask it to generate the prompt to recreate what has been done in the previous conversation.
Mm-hmm.
Now, not only was that useful just as a record so you could recreate it, because one of my bugbears was if you do something and then you start another session and you think you're doing the same thing again, it comes up with a different answer. The code's different.
Yeah.
If you get it to generate the prompt for you, it comes up with exactly the same code. Better than that, what my mate did was he had started off in one engine, say ChatGPT, took the prompt and went into another engine, and it came up with the same code.
Mm-hmm.
It was amazing how he went from one machine to another, and it came up with the same code.
Yeah.
The comments were slightly different, but practically the same.
And the reason for that is simply that what they're all doing is statistical, and they've been trained on very, very similar code bases.
Mm.
Basically, all the software they could find. Some have access to extra stuff,
Yep.
but basically they've vacuumed up everything on GitHub
Yep.
And a few other sites. So it's not that surprising that they will do the same thing given the same prompt.
Mm.
Even the same prompt isn't guaranteed to produce the same answer because there is a thing called temperature, a temperature setting in an LLM, which it effectively controls how random the choice is from the probabilities it sees about what it might say next.
Oh.
And one of the things that I can do in Spear GPT that you can't do in an interactive chat session is I can control the temperature. And sometimes I'll set it to 0, in which case it's absolutely deterministic. It will do this exactly the same thing every time.
That's interesting.
Noticed a question in the chat about Copilot. I have used it occasionally. It's not one of the ones that I've tended to use a lot, particularly with things like Pico. I had some not very good experiences in the early days. I should probably try it again. Any other?
So there's a question in the chat about Forth.
Oh,
which
I missed
Forth?
that.
I don't know. Not sure what the question means.
Oh, Forth, right. Why use Forth? The short answer is it's about as fast as C++ to run, and it's about as fast as Python to write. And I find I really struggle with C++. I think I've written in all of my career, I've written perhaps half a dozen C++ programs, all for the Arduino. And I think I've only written about 4 C programs. Rather surprisingly, the first serious C program I wrote actually got stolen by my marketing manager and given to a customer. And it's been in production for the last 35 years. But um, that's my only claim to any sort of C fame. I'm not a skilled C programmer. And so if I want something to run fast, then for me, Forth is a better bet than C++ would be. Oh, which Forth do I use? It's Zepto Forth. And I chose it almost by random, almost at random, but it's a very good implementation. I like the feel of it, and it's worked very reliably so far. I've not made huge use of it, but the things I've wanted to do with it have worked well. Couple more things.
I did find it useful. I was working with an HX711. It's a strain gauge
Uh-huh.
chip. ChatGPT was really useful to find the right a useful library.
Uh-huh.
Sometimes you just need help finding the right library
Yeah.
and getting a bit of code. So
Well,
it's
one of the things which I think I'm going to do in my copious free time, which ought to be plentiful given that I'm retired, but as I was saying to Richard earlier, I seem to be busier now than I was when I was working. But one of the things I want to do is a while ago I wrote a human-oriented checklist for which projects I felt happy using on GitHub. And there are questions like how recently has it been updated? How long does it take them to fix issues? When were the last pull requests resolved? Stuff like that. But also things which looked at code quality. And one of the things I want to do initially for me, but I'll share it, is write one of the MCPs, the freely available tools which most commercial chat agents can now use as part of their workflow, and write an MCP which will allow you to say, I want to find a GitHub library to do this, and it will do the evaluation for you and come back with a list of things which do what you want, but appear to be live, active product projects with decent tests and good code. And I think that could save quite a lot of time. But don't hold your breath. I've got a lot of stuff on at the moment.
you get to do code reviews for you. Can you like feed it your code and get it to comment on it like a professional code reviewer?
Um, I know there are people that do that, and I know there are people who have tried that and found it really good and really bad.
Right.
It depends so much. One of the issues is, which I touched on earlier, these have learnt from looking at code on the internet, and 90% of the code on the internet is bad code. Actually, 90% of all code is bad code. It's a miracle that anything ever works. But and if you think that that's me being troublesome, there's really strong scientific evidence that the code quality curve is very skewed with a very long tail. What I'm about to say will probably sound like madness to most people. I explain why it's not. Most code is well below average. Now, you'd think that was a contradiction in terms, but it's not, because if you've got a skewed curve as opposed to a normal curve, it's quite possible for the average to be significantly higher than the modal value, in which case most stuff is crap.
One application we found it good for was in a club website, which a previous webmaster had written in PHP. It was
Yes.
very good at documenting it for us and explaining what modules did.
Yes.
So it was good from that point of view, but it was on a very restricted base.
Yeah.
And we could
It
describe
can
the
be good
environment
at
very
doing that,
closely.
and I know some really quite complex applications where people have done that. Large code bases, complex code, some of them can do a very good job.
Mhm.
And the thing that really excites me, it frustrates me a bit as well, because I'm getting on in years, as you can see, and I want to see as much of this happen as possible. But the thing that's amazing is that the quality of LLMs for a given footprint in terms of resource they use is still growing really fast.
Mhm.
We're still seeing an improvement at the high end, but perhaps more important, we're seeing performance being delivered by smaller and smaller LLMs, which run faster. And I just can't wait to see what happens next.
Mm. So anyone have any experience using AI to do like 3D models, like so for 3D CAD designs? Just wonder if that's another
Uh,
application someone's been playing
I
with.
haven't, but that's one of the active areas of development. There's a lot going on with that at the moment.
Yeah, I think it'd be
And
really
certainly, if I do
interesting.
manage to get a 3D printer at some stage, one of the things I want to do is use AI to help me get my head around 3D modeling technology.
Hmm.
I think it'd be
That
really
that
interesting if
that
it
would be
can be
very
reviewed.
interesting. I'm not sure what tool set I would use to do it.
Uh, what did I'll see if I can find a link I saw a couple of days ago, and if I can, I'll put it up on the Raspberry Pi Facebook page. But I was just playing around with what could I do if I had the printer, and I came across something that looked pretty cool. I'll try and find it again and share that.
Yeah, I do spend a little bit of time asking it for like the best 3D printed desk and box holder sort of thing, things like that, and then just
Yeah.
sort of goes around and finds stuff that's highly regarded. And
But
it's
the one of the things which I'm probably not going to get around to till next year, but I really want to experiment with. There are now some very good open source 3D printed 5 or 6 degree of freedom robot arms, and writing AI code to use those to do quite complex manipulative tasks is possible, and that's something which I really want to explore. One of my sort of long-term projects is to look at ways of automating the rapid prototyping of electronics. And you can these days, for I think they cost about 1,500 quid these days, buy a fairly robust, simple, lightweight pick and place machine.
mm,
Once you start getting one of those and something which will automate some of the tasks in KiCad, and something which will automate the simulation of a network once you built it, and an engraver which will cut a PCB,
Hmm.
all of which are available at the moment. You can look at rapid prototyping of either single boards or short production runs very, very quickly. And that starts to get very interesting.
that's really incredible, isn't it?
Yeah.
Where this whole thing is headed is it's very exciting, like I said.
Yeah.
I mean, sitting at home, you can become a little factory. Really.
Yeah. Of course, you can do
Really
that
great
with software right
complex.
now. I mean, I'm just amazed at how much stuff. It's not just me. There's a whole group of us on who got to know each other on LinkedIn, and we've now set up our own private Discord. These are professional software developers, and what we're all doing is pushing the envelope of what you can build and how you can build it using AI. Um, and it's not just building projects; it's building tools. You can, yeah, software tools, but you can build extraordinary things very, very quickly now, as long
So,
as they're fairly simple.
so you're thinking about using AI to do things like PCB layout?
Uh, you bet. I mean, Google and I think Facebook use it not just for PCB layouts, but for um, silicon layouts. For,
All right. Yeah.
and AI does that job better than most humans do already.
I mean, have you come across people doing it for, say, prototyping for sort of maker type projects or?
Well, apart from me,
Oh, I see.
not yet, but
Oh,
I'm
okay.
sure there are.
Oh, no,
And one of the things which I wrote by hand a while ago
yeah.
as a tool called um, God, I ought to be able to remember the name of my own software, Breadboarder.
All right. Yeah.
And what Breadboarder did was you did a fairly simple Python script which specified what you were going to plug into a breadboard and how you were going to connect it all up.
Right.
And it would generate a diagram and step-by-step instructions for people.
Oh, okay.
And I just got fed up with it's fairly tricky code.
Yeah.
Particularly the bit that I hated was that if you wanted to get a decent image, you had to generate an awful lot of SVG that was based on physical measurements.
Yeah.
And it's a real pain. I suddenly realized the other day that AI could do all that for me.
Yeah. It would be nice if you could link KiCad into AI. That would be
Well, there's certainly people doing that. And
right.
uh, you can generate KiCad scripts with Python already.
Oh, okay. Right.
So if you can do that, you can get AI to write the Python and then
Ah, right.
and part of the magic of all of this is that one of the things that LLMs do really well is if you give them a bit of direction, they will take a completely unstructured document in English and turn it into something that satisfies a JSON spec.
Right.
So you can now write what you want in English and turn it into something which, from that point on, Python code or whatever can manipulate.
Oh, okay. Right. Yeah.
And that could be building a KiCad app or doing a breadboard layout.
Yeah.
One of the things I'm experimenting with at the moment is doing that to turn it into a business process model and then looking at that process model and working out which steps can be automated using AI.
Right. Yeah. I
So,
find you have to be a little bit careful. So I found I had a case recently where the AI lied to me.
oh, well, all the time.
Yeah.
Yeah,
I
you
asked
tricked
it
me.
about whether a certain TI part could report voltage over an I squared C bus.
Yeah.
Uh, and he gave a very clear answer that it could and very detailed answer how it does it, this particular part. But it was a complete lie. The part didn't do that at all.
So
Yeah.
I wasted
Yeah.
probably an hour, maybe 2 hours yesterday,
Yeah.
um, because I'd got hold of oh, it's gosh,
All right. Yeah. The
one
Explorer.
of those, the old Pico Explorer base, and I wanted to use it to drive an I squared C chip,
Right. Yeah.
and I couldn't remember which pins of the Pico that version of the Explorer used.
Right.
And I so I asked, I think it was ChatGPT,
Right.
and
Yeah.
it was absolutely firm about the answer. It gave me four wrong answers before eventually I
Right.
came up with one that worked.
All
I
right.
thought
Okay.
I'm doing something stupid. I'm using
Yeah.
the wrong pins. I'm using the wrong channel. And
Yes.
no, it was just lying.
Yeah. Yeah.
So yeah, I mean, this stuff is magical, but it's a bit like rubbing the bottle, and the genie comes out and does what you
Yes.
asked for if you're lucky, but it
Yeah.
might not be what you want.
No, that's right.
And
Yes. Yeah. The trouble is, it tends to give very plausible answers, but you do have to check them. You do have to.
absolutely, I mean,
Yeah. Yeah.
it is. I know how these things work
Right.
in
Right.
some detail. I've been
Right.
playing around with AI since
Yeah.
1974.
Oh, okay. Right.
Um,
Yeah.
and yet I still behave as if I were talking to a person.
Yes. Yes.
Um,
Yes. That's
it's very
interesting. Yeah.
seductive and very
Yeah.
dangerous.
Yes. Yes. No, that's a good point you made there.
Yeah.
Yes. That's, oh, thank you.
That's a pleasure.
Thank you.
Any more questions?
Questions?
If you think of things and you use the Facebook page, ask away in the future. Happy to answer if I can.
Oh, brilliant.
Yeah,
That was
I don't think
a
so.
very
Thank
interesting
you.
introduction. Thank you very much. Thank you.
Great. Glad it was useful.
Thank you.
Thanks
And
very
it's
much.
all fun too.
It was like quite an adventure.
Yeah.
Uh,
Great.
Well, thanks so much, Romilly. Thanks so much.
That's a pleasure.
It's really, really good session.